Video 62. Problem number 2. Prove by induction that 1 by root 2 plus 1 by root 2 plus etc. plus 1 by root n is strictly greater than root n for n greater than or equal to 2. Proof. Let P of n be the statement 1 by root 1 by root 2 plus etc. 1 by root n which is greater than root n. Then we write P of 2 first because we want to prove n is greater than or equal to 2. P of 2 is, now in P of n there are n terms, root 1 to root n there are n terms. In P of 2 we have only 2 terms, root 1 plus root 2 is greater than root 2. P of k is, there are n terms here, 1 by root 1, 1 by root 2 plus etc. plus 1 by root k is greater than root k is P of k. P of k plus 1 is 1 by root 1, 1 by root 2 plus etc. plus 1 by root of k plus 1 is root greater than root of k plus 1. Now we have to go to the basic step. We need to prove P of 2 is true. N is greater than or equal to 2. P of 2, we have, what is the left side of inequality is 1 by root 1 plus 1 by root 2 is equal to 1. Root 1 is 1 plus 1 by root 2. 1 by root 2 multiply both numerator and denominator by root 2, which is 1 plus root 2 by 2, 1 plus 1.414 approximately by 2, so approximately equal to 1 plus 0.707, which is 1.707. And what about the value of root 2? Root 2 is approximately equal to 1.414. So 1.7 is greater than. Since 1.707 is greater than 1.414, it follows that 1 by root 1 plus 1 by root 2 is greater than root 2. Therefore, P of 2 is true. P of 2 is true. Assume that P of k is true. Induction step. Assume that P of k is true. That is 1 by root 1, 1 by root 2 plus etc. plus 1 by root k is greater than root k. Now we need to prove P of k plus 1. So this is the extra term. Add 1 by root of k plus 1 on both sides. Therefore, 1 by root 1, 1 by root 2 plus etc. 1 by root k, added term is 1 by root of k plus 1 is greater than root k plus 1 by root of k plus 1. So this is equal to, we can take LCM. What will happen here is root k equal to root of k plus 1 LCM. Root k into root of k plus 1 plus 1 plus 1. This quantity is greater than, this quantity is greater than root k. Root of k plus 1 is replaced with root k plus 1 by root of k plus 1. that is this root k is written as it is. Instead of root of k plus 1 you have written root k, so this gets smaller. Now root k into root k is k plus 1 by root of k plus 1, k plus 1 by root of k plus 1 by root of k plus 1. So thus what we have proved is thus 1 by root 1 plus 1 by root 2 plus etc. up to 1 by root of k plus 1. This is strictly greater than last term root of k plus 1. So we are adding this term on both sides, take LCM, and this root of k plus 1 is replaced with a smaller quantity root k. Root k into root k is k. K plus 1 by root of k plus 1, root of k plus 1. Therefore, p of k plus 1 is true if p of k is true. We have p of 2 is true. P of 2 is true. This is our second statement. Therefore, by 2 for the next integer p of 3 is true. P of 3 is true. Therefore, by 2 next integer p of 4 is true, etc. P of n is true for any integer n greater than or equal to 2. This is what is required. So this completes video 16.